In a previous lecture, we discussed a computer system in terms of some basic functions of all systems: input, process, and output. And in particular, we discussed the hardware related to this. In this lecture, we're going to take a little bit different view of a computer system, and much of the emphasis of this particular discussion will be on the software itself. I've been using this pyramid for some years, although it's changed over the years, of what constitutes a computer system. And at the very bottom, we start off with hardware. And hardware is the nuts and bolts and peripheral devices: the computer, the memory, the hard drives, the printers, the monitors, and so forth. But by themselves, they are not particularly useful. In order to function, there must be software that actually runs those devices. And the software that actually runs the hardware on a computer is called system software. And it's responsible for managing all those resources on the computer. But then above that, in our computer system, we have application software. And this is software. It's slightly different from the other, because this software responsibility is to handle user requests, user requirements. It's your word processing, your spreadsheets, your accounting software, and so on. A section of the pyramid that's been added in the last 10 years has been this section right here: communication infrastructure, because in this day and time, an honest evaluation of a computer would suggest that one that does not have access to the internet is not very useful, because so much of what we do these days is involved around our network and our internet access. Today we are accessing data on remote computers in other places, sometimes in other countries. We are storing our data now in the cloud in some respects. We're using services like Dropbox and Google Drive and SkyDrive instead of worrying about upgrading our local hard disk every time a new one comes out with some expanded space or new features. Now we just let somebody else worry about that, and we just rent the space in the sky. There's another layer that we're going to discuss right now: policies and procedures. Because the fact of the matter is, you can have the best piece of computer hardware in the world. You can have the finest operating system, whatever your preference happens to be: Windows, Mac OS, Linux, any number of different operating systems out there. And you could be using the best applications that money can buy with a high-speed internet access. But if you don't have proper policy and proper procedure, most of this other stuff can be pretty much useless. For example, if you don't have a policy that says we're going to back up our data on a regular basis, then when a device fails, a storage device or some other device fails, all of a sudden this supercomputer and wonderful software is really not worth much, because our data disappeared. If you are accessing places, let's call it digital promiscuity, accessing websites without any kind of care, you could be gathering viruses and other types of malware that could damage your computer. And therefore, having proper policies and well-documented procedures in a modern computer system is critical. And then at the very top of our system, we have the user. And the user, I've often heard and probably said, I know I have said, is the weakest link in all this. This is where the mistakes are made. I sometimes take a little bit different view of the user than some others, because I consider the programmer that wrote the code a user. I consider the administrator that runs the system a user. And therefore, when things don't work right, it's some user's fault, probably, unless it just happened to be a failed piece of equipment, which you might be surprised is fairly rare. And so what do we need for users? We need them to be well trained. We need them to use good sense when they're accessing things on the web and so on. And so the users are a critical part of this system. Now what we're going to do now is discuss some of these issues and some of these layers individually. And we're going to start with system software. And system software consists of a number of pieces. You see 3 right here: operating system, compilers, and utilities. Operating system, this is the software that most of us are fairly familiar with, whether we are Windows users or Mac users, Linux users. We understand that the operating system is the software responsible for managing the resources. It's the resource manager of the computer. It is critical. In the early days, before the operating system was created, you recall from our history discussions that the first programming languages came about in the mid-50s, Fortran and COBOL. But in that point in time, there was no operating system. Therefore, when the programmer sat down to write code, much of the time spent coding had to do with moving things around in the computer and making things in the computer work, more so than actually accomplishing whatever the application was that they wanted to accomplish. More programmers' time was spent doing housekeeping, let's say, than actually programming the application that we needed. And then in the 1960s, the manufacturers introduced another concept. They stuck another layer of software between the hardware and the application and made that software responsible for managing all of these resources, so that now the programmer could concentrate on programming the app and not spend his time worrying about moving things around in memory. And the operating system took the responsibility. So now the programmer writes his programs for the operating system, not the hardware. So the operating system is a very important part of our system. Compilers. We know that computers don't speak English. Computers speak eventually nothing but binary code, zeros and ones. We can't write code in zeros and ones. Now there is a very low level of programming code called machine language that has a few cryptic commands that the early programmers had to use in order to command the computer to do its thing. But it was still a very difficult language for a human being to use. And so these programming languages were created. COBOL. Fortran was the first one, COBOL. A number of others came along after that until in around 1970 Bell Labs created the C programming language, which actually became a dominant programming language for many years. And then there have been a number of variations. There were other programming languages like Pascal, and Java has come along as it's become a very popular programming language. But the thing is, computers don't speak Java. They don't speak C. They don't speak COBOL. They speak at the very highest level machine language. At the lowest level, binary. So therefore, if we're writing code in COBOL or C, somehow that code has got to be converted to machine language or binary. And the tool that does that is the compiler. A compiler will take the code you've written and convert that code to the language that the computer can understand. And compilers are a form of system software, just like the operating system is. They come in a couple of types, the compiler for one and an interpreter for another. And The difference is a compiler will, is that ER or OR? I don't know how you spell interpreter. The compiler will convert the whole program at one time and then create a new file in machine language. Whereas the interpreter, if you could read that terrible writing, the interpreter will convert the program as it runs and execute. Two different approaches to solving the problem. And then another area of system software are utilities, where you have the software that you run to do things that basically keep the system working. Like formatting a disk, that's a utility. Defragmenting a disk, that's another utility. Software packages like that are classified as system software utilities. And this level of software is very, very important to us, because it really is the part that's responsible for keeping our system functional and working. Now let's take a look at a little more detail about the operating system. Now what you see here is a picture of a computer, and you see it's attached to a printer, and I see a graphic of a disk drive. And you have to understand that that disk drive that you see pictured right here is actually inside this case right here installed. And the operating system actually knows, for example, how to make this printer boldface text. It knows how to make this printer eject a page, condense its print so that it can print 17 lines per characters per inch instead of 10. It knows where it is. We talked in an earlier lecture about ports. Well, the operating system knows which port leads to this printer. That's its job. And as far as this monitor is concerned, the operating system knows how many pixels it's got and how to turn on its colors and how to minimize and maximize and move things around on the screen. In fact, as you drag your cursor across the screen, it knows how to move that little arrow for you. We talked previously about the microprocessor. Do you realize as you move that little arrow across your screen that what's going on is your operating system is commanding the microprocessor to paint that arrow while it almost simultaneously erases it from its last position. As it goes across the screen, that arrow is being painted, erased, painted, erased, painted, erased so fast that you don't even see it. In the early days with slower microprocessors, when you would drag that cursor across the screen very quickly, quite often you would see a string of little arrows going across there because it was not erasing quite fast enough. But the point is, the operating system knows how to make that monitor work. The operating system knows how to make this keyboard right here work, and this mouse, how it controls that. It knows where the RAM is on the motherboard that's inside this box, and knows all the memory addresses and how to access them and store things to it and remove things from it. The operating system has complete control over this system, and it makes no difference what operating system you're talking about. They all do essentially the same thing. Now, operating systems have what is referred to as a user interface. And a user interface is how you interact with the operating system. And for years, it was text-based. And we would sit down, we would get this little prompt, cryptic little prompt, sort of like that. And there would be a blinking insertion point right there, and we would have to type in the command. In order to use this computer in those days, you actually had to know the command. And then with Mr. Engelbart's mouse and the graphical interfaces that we came up with, the graphical user interfaces that we came up with. Now you can point your mouse at a trash can and delete a file. You can point your mouse at a picture of a diskette and save a file. So the operating system can be have a text interface, or it can have a graphical user interface. That's what GUI stands for, graphical user interface. Two different kinds of user interfaces. We've been talking about how the application software communicated with the computer through the operating system, but you as a user also do that, because you will ask the user to show you a list of files. You're dealing directly with the operating system. You're probably using one of those system utilities we talked about, for example, File Explorer, and to be able to accomplish that task. So the operating system is the person in charge, the thing in charge. It knows how everything works, how to make it work, and how to keep everything running. Now then, application software, the stuff that we use all the time. Software like Microsoft Word, Microsoft Excel, Microsoft PowerPoint. I don't know why I have spreadsheets and presentation here twice. We got accounting software like Quicken. Yeah, the old professor's one of his favorite things. As a matter of fact, you know, we're talking about these operating systems. I have been a system administrator for a number of years, and oftentimes my younger staff will be saying things like, well, you know, why don't you get away from that old Windows operating system and join us in Linux. Linux is the way to go. It's much more efficient. It works much better. And I have one simple question for them. Does it run Quicken? If the answer to that question is no, then I don't care anything at all about going to another operating system, because you see, it's not your Mac OS or your Windows operating system or your Linux operating system that makes it work for you. It is your software that you use to do the things that you want to do. And so when I'm looking at a computer, I'm looking at it in terms of, will it run the stuff that I want to run? In this case, we're talking about Quicken. And if it will, and it is somehow an improvement over what I've got, then I'll consider it. But there's any number of different applications out there besides these. How about changing that word spreadsheet with games? And let's see, how about changing presentation, if you will, in your mind to databases? All sorts of different kinds of application software. Now, in the case of databases, I tend to sometimes have a little bit of a different point of view about a database. I tend to view database software packages more like system software than I do application software, because there's a real technical aspect to developing files with a database, where one really needs to understand how data is recorded, how it can be retrieved, and an efficient way to use it. And so I sometimes tend to view database as something other than application software. But a lot of people still do. They consider their Access just another one of their apps that they run, and that's fine. Now, the next layer of our pyramid, we talked about communications infrastructure, and the first thing in your computer is the network interface card. It's called a NIC. Now, some of the motherboards that we looked at earlier have the network interface card built into the board. When they first came out, of course, they didn't, and so we bought one of those cards to plug into one of those I/O slots, if you recall, to plug in there to connect us to the network. And basically, the network interface card connects you to the next device in the network. And usually that next device is in this group. It is a switch or something along those lines, switch or a hub. These are types of devices that allow multiple computers to connect together. In other words, your computer with your NIC in it will connect to a switch over here along with a lot of other people in their computers, and they're all connected to that same switch. And then the difference between a switch and a router, quite frankly, is that the router is the part that knows how to get you to the other side of the globe. It understands how to route packages, route your communications to systems outside of your own. Switch, on the other hand, is pretty much limited to the internal network. But you've got the network interface card, you've got switches, but once you leave the building, or once you leave the campus, there's got to be somebody else to pick up the slack, and that somebody else is the ISP. That stands for Internet Service Provider. And by the way, Internet, when in this context, usually comes with a capital I, provider. And the Internet Service Provider is your link to the rest of the world. Now, what other types of devices do we have at this communication infrastructure? Well, we've got all sorts of wires. You've seen the wires in our labs, or the labs at your school. They are usually a twisted pair is what it's called. But you're also connected, you may be connected through other types of cabling. And then the little connector that you plug into your computer, there are standardized specifications for those things, and they're all part of the infrastructure. And then right now, what we all tend to favor are wireless access points, because now I don't have to connect to some wire and be tied down like a horse up to the fence. I can now move about and communicate at will because I have a wireless access point available, and it picks up my messages and transfers me around. So once again, this is just another layer, communication infrastructure, of this view of a computer system, and it's a very, very important layer, and these are the various components that go into this. Okay, policies and procedures. We're talking about this, that a lack of this can cause all that other stuff to be pretty much useless. An internet policy basically that states where you should and should not go, the kind of sites that you attend, and what you do on those sites, whether you are allowed to download at will or whether there are restrictions on you. Security policies, such as you will use a password if you connect to our system, and your password will change periodically. And sometimes they go even further and say you won't use certain types of computer, you won't use certain types of programs. There may be security policies against downloading anything. Downloading might be a violation, and if you're on a work computer, you have to understand it's not there to play on, and they are very concerned about keeping it up and running so they can do whatever their job is. Privacy policy. Do you have a right to expect information about yourself to be kept private? Well, you do. And so as a result, organizations have privacy policies where they tell you what they will and will not do with the information that you give them. Part of the value of the internet is being able to access your stuff, that being buy from Amazon your books, or to deal with your local e-trader to buy and sell your stocks, or deal with a bank. And in order to accomplish that task, you're usually required to give them certain information, and you have a right to know what they will and will not do with that information. So you've seen here a number of the issues that go into making up a computer system, and the last one is the user. And I would suggest to you that the biggest weakness of most organizations is they don't spend the money to train their staff properly. Oh yes, they may have a training session when you first get a new product in. Everybody's going to learn how to use this, and then they don't do it again. And people come and go, and people who knew how to use it before left, and people who may have forgotten some of it, and they're not training their people. And so as a result, Your users need to know that security policies, for example, are just as much there for their benefit as it is for the organization's benefit. If something happens that damages the organization's system and they trace it back to one's user ID, that user could be in serious trouble. Whether or not that user actually did it, or whether they just got up and left their computer logged in and somebody else sat down and did it. So the users need to be well trained, and they need to be indoctrinated, or at least taught, that measures like the one we've described here, security, internet policy, and these kind of things, are for their benefit as much as anybody else's. And I believe that's going to conclude this